The stars are leaving US on January 9, 2025. An astronomer in Chile noticed something that shouldn't be possible. A galaxy, NGC 4622, roughly 111 million light-years away, had shifted position. Not drifted. Not rotated. Shifted. By 0.03 arc-seconds in just 6 years. That doesn't sound like much. But at that distance? That galaxy had moved 47,000 light-years. In 6 years. That's 26 million times faster than the speed of light. Impossible. Except it wasn't just NGC 4622. By February 2025, amateur and professional astronomers had identified 247 galaxies showing the same impossible movement. All moving in the same direction. All accelerating. All moving away from Earth. Not expanding with the universe. Not following Hubble's law. Not obeying any known physics. Fleeing. By March 2025, the James Webb Space Telescope confirmed what everyone was afraid to say out loud: the effect was spreading. Galaxies that were stationary in January were moving in March. Dozens more every week. The observable universe is running away from us. And it's accelerating. To understand what's happening, you need to understand what the universe is supposed to be doing. In 1929, Edwin Hubble discovered that galaxies are moving away from us. All of them. The farther away they are, the faster they're receding. This became known as Hubble's law, and it's the foundation of the Big Bang theory. The universe is expanding. Not like an explosion from a center point, but like the fabric of space itself stretching. Every point in space is moving away from every other point. It's not that galaxies are flying through space, space itself is growing. And for 96 years, this model worked perfectly. We could predict galactic positions, measure cosmic expansion, calculate the age of the universe. 13.8 billion years. Everything fit. Until January 2025. Dr. Maria Escalante, working at the Paranal Observatory in Chile, was conducting a routine verification study. She was comparing archival Hubble data from 2019 with new observations from 2025, tracking galactic positions to measure cosmic expansion rates. Standard work. She'd done it hundreds of times. She expected to see galaxies roughly where Hubble's law predicted, slightly farther away than they were 6 years ago, moved by the expansion of space. NGC 4622 wasn't where it should be. Not even close. Her first assumption: instrument error. She recalibrated. Ran the measurements again. Same result. Her second assumption: data corruption in the Hubble archive. She pulled observations from 3 other telescopes, including JWST. All confirmed the discrepancy. Her third assumption: she made a mistake in the calculations. She asked 2 colleagues to independently verify. Both came back with the same number. NGC 4622 had moved 47,000 light-years in 6 years. Moving at 7,833 times the speed of light. She checked nearby galaxies. NGC 4618, NGC 4625, NGC 4631, all showing similar anomalies. All moving faster than light. All moving in the same direction. She published a preprint paper on January 12, 2025. It was supposed to be peer-reviewed, cautiously announced, carefully analyzed. Instead, within 48 hours, 400 astronomers had confirmed the effect in their own data. Within a week, it was headline news. Within 2 weeks, governments were holding emergency sessions. Because this wasn't just surprising. This was civilization-alteringly terrifying. Nothing moves faster than light. It's not a speed limit like 65 miles per hour on a highway that you could break with a better engine. It's a fundamental property of causality. Moving faster than light means moving backward in time. It means breaking cause and effect. For a galaxy to move faster than light, one of 3 things must be true. Either our understanding of relativity is completely wrong, or something is fundamentally changing the laws of physics in those regions of space, or something is pushing them. Something with more energy than should exist in the observable universe. On February 3, 2025, a graduate student at Caltech named David Yoon was reviewing the data when he noticed something everyone else had missed. The galaxies weren't all moving at the same speed. They were accelerating. But not uniformly. The ones closer to us were accelerating faster. The ones farther away were accelerating slower. As if they were feeling a push that decreased with distance. A push originating from the Milky Way. From us. From Earth. We weren't observing distant galaxies fleeing from something out there. They were fleeing from here. From our location in space. From the local group. From the Milky Way. From Earth. When the scientific community realized Earth was at the center of this effect, 3 theories emerged. Each one more unsettling than the last. Theory 1. We're in a privileged position. Earth happens to be at the exact center of a universe-wide expansion event. Pure coincidence. Cosmological lottery. The odds of this? Roughly 1 in 10 to the power of 23. That's a 1 with 23 zeros. More unlikely than winning the lottery every day for 1,000,000 years. Scientists don't like coincidences that unlikely. When you're that special, you're not special, you're wrong about something. Theory 2. We're not observing galaxies moving. We're observing a change in spacetime itself. Some kind of expanding bubble of altered physics, centered on our location, making distant objects appear to move. This would explain the faster-than-light speeds. They're not actually moving through space. Space itself is changing its properties. Like a lens distortion that makes things look farther than they are. But this theory has a problem. The light from those galaxies is still reaching us normally. If spacetime were that distorted, we'd see gravitational lensing, redshift anomalies, spectral distortions. We don't. The galaxies are physically there. And they're physically moving. Theory 3. We did something. Sometime in the recent past, humanity activated something. Built something. Discovered something. And it's producing a repulsive force so powerful it's ejecting galaxies from our cosmic neighborhood. The Large Hadron Collider. CERN's particle accelerator. The most powerful machine ever built. Since 2008, it's been smashing protons together at 99.9999991% the speed of light, recreating conditions that existed microseconds after the Big Bang. In 2012, it discovered the Higgs boson, the particle that gives other particles mass. In 2022, it was upgraded to even higher energies. In 2024, it began experiments probing quantum vacuum stability. Here's where it gets terrifying. Our universe might be in a false vacuum state, a temporary, metastable condition. Like a boulder perched on a hill. Stable, until something pushes it. If something, say, a high-energy particle collision, creates a true vacuum bubble, a region of lower energy spacetime, that bubble would expand at the speed of light, consuming everything, fundamentally changing the laws of physics as it spread. But that's not what's happening here. Galaxies are moving away, not being consumed. unless we created a negative vacuum bubble. Not lower energy, but higher energy. A region of spacetime with increased vacuum energy density. And that creates negative pressure. Repulsion. On March 1, 2025, CERN released a statement. In December 2024, during a high-energy collision experiment, they detected an anomaly. A collision that produced more energy than it should have. Specifically, 10 to the power of 19 electron volts more. That's the energy equivalent of the largest cosmic rays ever detected. From a collision in a laboratory. The excess energy had to go somewhere. They theorized it had punched through into a higher dimension. Briefly. For less than 10 to the power of 23 seconds. And when it snapped back, it left a scar. A defect in spacetime. A defect that's been growing ever since. Think of spacetime like the surface of a pond. Smooth, stable, predictable. Now imagine dropping a stone into it. Ripples spread out. But what if the stone punched through the surface? What if there was nothing on the other side to catch it? The hole doesn't seal. It grows. And everything around it starts falling toward the hole, or, from another perspective, being pushed away from it. You need to understand something about general relativity, mass and energy curve spacetime, creating gravity, attraction. But negative mass, negative energy, would create negative curvature. Anti-gravity. Repulsion. If the LHC accident created a pocket of negative energy in higher dimensional space, and if that pocket is expanding, leaking into our three-dimensional universe, then Earth isn't just at the center of the effect by coincidence. Earth is the source. We're the infection point. The tear in reality. And we're pushing the entire universe away. But here's what's keeping physicists awake at night. Here's the part that transforms this from a scientific crisis into an existential one. If galaxies are accelerating away from us, and if they're already moving faster than light, then the light they're emitting now will never reach us. Ever. Even if they existed forever, even if they shone a laser directly at Earth, the light would be swept away by the expansion, perpetually receding, never bridging the gap. They're crossing the cosmic event horizon. The edge of the observable universe. Once they cross it, they're gone. Forever. From our perspective, they cease to exist. And the boundary is shrinking. Every day, more galaxies cross it. Every day, our observable universe gets smaller. In 2025, we could see 200 billion galaxies. By 2030, at current acceleration rates, 150 billion. By 2050, 50 billion. By 2100, 5 billion. By 2500, none. In 475 years, humanity's descendants will look up at the night sky and see nothing beyond our local group. No distant galaxies. No cosmic microwave background. No evidence of a larger universe. They'll think the Milky Way is the entire universe. They'll have no way to discover the Big Bang. No way to measure cosmic expansion. No way to know that billions of galaxies once existed beyond their view. We're not just losing the stars. We're losing the truth. We're being isolated from cosmic reality itself. On April 15, 2025, an emergency session of the UN was convened. Not publicized. Closed doors. Heads of state, top physicists, military advisors. The question wasn't whether to shut down the LHC. That was obvious. The question was whether it would matter. Because the damage might already be done. The tear in space-time might be self-sustaining now. Like a fire that's grown beyond the spark that started it. Dr. Yuki Tanaka, a theoretical physicist from Tokyo, presented a simulation to the Council. A model of what happens if the negative energy bubble continues expanding. Phase 1, current state. Distant galaxies fleeing. Observable universe shrinking. Disturbing, but not immediately dangerous to Earth. Phase 2, local effect. As the bubble grows, it begins affecting nearby stars. Alpha Centauri, Proxima, Barnard's star. They start accelerating away. Within 50,000 years, the nearest star is tens of thousands of light years away. Earth is stranded in an island of darkness. Phase 3, gravitational collapse. Our solar system's stability depends on the gravitational framework of the galaxy. As more stars are pushed away, the galaxy's mass distribution changes. Orbits destabilize. Stars flung into intergalactic space. Planets torn from their suns. Phase 4, quantum decay. The negative energy bubble doesn't just push matter, it alters vacuum structure. Fundamental constants begin shifting. The strong nuclear force weakens. Atoms can't hold together. Matter dissolves into radiation. The simulation ended with Earth, isolated, dark, orbiting a dying sun in a galaxy torn to pieces, experiencing the breakdown of atomic structure itself. Humanity wouldn't die from lack of light or heat. They'd die from physics itself ceasing to function. The council chamber was silent for 11 minutes. No one spoke. No one could. Then someone asked the question everyone had been avoiding. If we're the source, and if we're pushing everything away, what happens when the bubble reaches us, Dr. Tanaka ran the calculation. The negative energy bubble is expanding outward at an accelerating rate. But it's also growing inward. Like a sphere inflating, the outer surface moves out, but the inner surface has to expand too, eventually. Currently, Earth is inside a safe zone. The center of the bubble, where spacetime is still mostly normal. But that zone is shrinking. In approximately 12,000 years, the negative energy front reaches Earth's position. And when it does, one of three things happens. Outcome 1. We're ejected. Earth, the Sun, the entire solar system is accelerated to faster than light speeds and flung into intergalactic space. From Earth's perspective, the galaxy would vanish in an instant. We'd be alone in the void, forever. Outcome 2. We're dissolved. The negative energy fundamentally changes the quantum vacuum in our location. Matter can't exist in the new physics. Every atom on Earth dissociates simultaneously. Instant, total annihilation. Outcome 3. We phase. If negative energy creates a bubble into higher dimensional space, we might be pushed out of our three-dimensional universe entirely. Where we'd go, what that would mean, no one knows. We'd simply cease to exist from the perspective of normal spacetime. 12,000 years. It sounds like a long time. Longer than recorded human history. Enough time to find a solution, you'd think. But here's the problem. The problem that makes this a crisis right now, not in some distant future. In 475 years, we lose the ability to study the cosmos. In 500 years, every observable galaxy except the local group is gone. All evidence of cosmic expansion, the Big Bang, the nature of spacetime at large scales, erased from view. Imagine trying to solve a problem when the evidence you need to understand it is being actively destroyed. We have maybe 200 years before the universe becomes so observationally limited that we can't gather the data needed to reverse this. We're in a race against our own ignorance. And the finish line is darkness. But there's something else. Something that emerged in the classified sections of Dr. Tanaka's report. Something that changes everything. When CERN analyzed the exact moment of the December 2024 accident, they found something in the data. A pattern. Not in the particles. In the quantum vacuum fluctuations around the collision point. A pattern that looked organized. Structured. Almost like information. When they decoded it, assuming it was some kind of quantum artifact or measurement error, they found a repeating sequence. A number. Coordinates. The coordinates pointed to a specific location in space. 2,300 light-years away. In the constellation Cygnus. There's nothing unusual there. No bright star. No known nebula. Just empty space, according to every telescope we've pointed at it. Except when they used gravitational wave detectors. When they listened to the spacetime ripples from that location, they found a signal. Repeating every 1.618 seconds. The golden ratio. Not natural. Not random. Artificial. Something is there. Something we can't see with light, but can detect through gravity. Something that's been broadcasting for an unknown length of time. And here's what's truly terrifying. When they calculated the mass required to produce those gravitational waves, they got a number that shouldn't exist. Negative mass. Exotic matter. The same thing the LHC accident supposedly created. Whatever is at those coordinates, it's made of the same impossible physics that's tearing our universe apart. And it's been there for at least 2,300 years. Because that's how long light, and gravity, takes to reach us from that distance. Which means we didn't cause this. We didn't create the first negative energy anomaly. We just made another one. We replicated it. We're the second tear. And if there are two, if this has happened before, how many others are there? The Fermi paradox asks, where is everyone? Where are all the alien civilizations? Maybe they're not silent. Maybe they're not hiding. Maybe they're not extinct. Maybe they reached a certain level of technology. Built their own particle accelerators. Probed the quantum vacuum. Punched through to higher dimensions. And maybe, every single time, they created a tear. Started pushing their universe away. Isolated themselves. Not on purpose. Not as punishment. Just as an inevitable consequence of asking questions that are too fundamental. Of probing too deep. Of touching the infrastructure of reality itself. We've been searching for alien signals for decades. Radio. Light. Gravitational waves. But what if advanced civilizations don't broadcast outward? What if they can't? What if the act of becoming advanced enough to communicate across the cosmos is the same act that pushes the cosmos away from you? We're not looking at an empty universe. We're looking at a quarantined one. Each civilization in its own cell. Each one pushing everything else away. Each one doomed to watch the stars leave, one by one, until they're alone in the dark. And we just joined them. The stars aren't leaving us. We're pushing them away. And we always were. From the moment we split our first atom, built our first accelerator, asked our first question about the fabric of reality. Every discovery brings us closer to understanding the universe. And every understanding pushes the universe further away. In 12,000 years, the bubble reaches us. But in 475 years, the darkness reaches us. The observational darkness. The ignorance. We have 475 years to solve a problem that might take 10,000 years to understand. We have less than 5 centuries to reverse physics we've only just begun to comprehend. Or we accept the alternative. That this is the great filter. Not nuclear war. Not climate collapse. Not AI. This. The moment a civilization becomes smart enough to look at the universe looks away. And maybe that's by design. Maybe that's the point. Maybe consciousness, observation, measurement, maybe these things aren't meant to probe too deep. Maybe reality has an immune system. And we just triggered it. The stars are leaving. Have been leaving. Will continue leaving until the sky goes dark and humanity is alone with the questions we should never have asked. We wanted to know if we were alone in the universe. Now we're going to find out. The hard way. CERN is still shut down. The UN formed a task force. We're calling it the Cosmological Preservation Initiative. We have 475 years to understand exotic matter, negative energy, higher dimensions, to find a way to seal the tear, to stop the expansion, to bring the stars back. Or we have 475 years to prepare for an eternity alone. Either way, when you look up tonight, remember, every star you see is running away. And tomorrow night, there will be fewer of them. The countdown has started. Watch them while you can.